Well, hi there. Welcome back to another session of Math 103. We are going to continue on working with more information involving the golden rectangle. And so I hope you will enjoy this. It's a little different, but I think you'll find it quite enjoyable. So we're going today to take a look at what you saw with the construction of the golden rectangle video that you were to have watched before the weekend ended. And we're going to continue with that with more discussions about the crazy things that are out there in relation to the golden rectangle. First thing I thought we'd do is take a couple minutes and take a look at, let me share the screen here first for you so that you can see what we're doing here. All right, let's see. Oh, right, here we go. Okay. Now, we're going to do two video quizzes today, and they are going to, I want them to be turned in to me before Thursday, if you could please. And on these video quizzes is material involving the golden rectangle and some material involving what are called golden sections, which I will discuss with you today in this class. So before we get into those, I thought we'd take a minute and review a little bit. Here is the picture of a golden rectangle construction. Remember in the video I did for you, we had a square, and we took this square and in it we bisected the bottom portion of the square. When we did that, we joined a line segment up to the top here, which I'm tracing out with the double arrows here. And when I hooked that up to the top, like so, I drew an arc down to the very bottom and extended the bottom length of the square, which added a small rectangle here on the corner of the square to the left. Okay, the triangle that was formed here, if you recall, has a very special name. It is called a golden triangle. And in a golden triangle, you want to remember that one of the legs is twice the length of the other. So if you take the shorter leg and double it, you will get the length of the longer leg. So please keep that in mind. That gives us the distance from here to here, which was the radius of this arc, as square root of 5 using the rule of Pythagoras. And when we drew that arc down to the bottom, we had a distance of radical 5 down here as well. Now, Dr. Ed will go over the construction of the golden rectangle with you briefly today in the video I'm going to ask you to watch in a few minutes. But I just thought we'd take a couple seconds to review it. We found that if we took the length of this, which was 1 here, plus the square root of 5, and we put that over 2, we had what was called, as you remember, the golden ratio. 1 plus the square root of 5 all over 2, okay? And with that in mind, we started talking about the golden rectangle. So here are some pictures of some examples of golden rectangles. And these are ones I took around my house. If you look to your upper right corner here, this looks like a thermostat. That's pretty close to a golden rectangle. Its length compared to its width is the golden ratio, probably 1 plus the square root of 5. Now the base of this clock, if you look at it over here on the left, the base of the clock appears to be a golden rectangle, but I'm not sure if it is or not. It looks like the thermostat is more like one, but hey, you know, what are you going to do? There are examples that we can look at of perhaps a golden rectangle. I think this might even be a golden rectangle. This window pane here, you can tell this picture was taken in the fall, looking out our backyard and onto our backyard, but this is definitely appears to be like a golden rectangle here. Now, don't be afraid of the next picture, but some ugly guy took it, and the mirror itself, I believe, also is a golden rectangle. Disregard the guy in the middle, okay? And this little timepiece here also could very well represent a golden rectangle, particularly the outer rectangle here. Looks like it could appear to be golden. And also this thing about mom and dad that we were given by the kids once upon a time. This really looks like a golden rectangle here. So these are just some simple examples. You can find golden rectangles everywhere. Today you're going to be watching some video that has interspersed into it some Walt Disney video, cartoon video that was done in 1958. So I've overlaid some of that video in some of Dr. Ed's talk so that you can get some more ideas about the golden rectangle and how it can be seen in all kinds of different places. All right, notice this diagram. Now this is a little weird. This is Hurricane Sandy back from October 2012. And this diagram is actually going to become a little more familiar to you once Ed talks about the golden rectangle a little more carefully in the second video presentation that he will do today. All right, the first thing I would like to concentrate on with you today is what are called golden sections. Now I'm going to change the view here, make these a little bit larger, okay? So we'll do it this way, and now you'll be able to see this a little better, perhaps. If you have line segments that appear to be like this, that show the following properties, they are said to be indeed golden sections. Now, when you hear the words golden section, you realize, of course, that golden sections probably have something to do with the golden ratio, right? And the reason these are called golden sections is this. If you have a segment configuration like you see here, and if you take the shorter length segment, which is CD, add to it the longer length next to it to the right, EF, if you add their two measurements together, you should come up with the length of the longer segment, which in this case, of course, is denoted by AB. But that's not the only thing that has to be present as a property of these three segments. That is one of them. There are two other properties that have to be satisfied. If you take what I call the middle length guy there, EF, and you divide the length of EF by the length of the shorter guy over there, the segment CD, you should get the golden ratio phi. Also, if you take the longest segment, AB, and you divide it by the middle length segment, EF, you should also get phi. So these are referred to as golden sections if those three properties are satisfied. The two shorter ones add up to the length of the longer one. If you take the middle length of the segment and divide it by the shorter length segment, you should get phi. If you take the longer length segment, AB up there, and you divide it by the length EF, the middle length segment, you should also get phi. If those configurations do exist with those segments, they are then referred to or called golden sections. Okay, we're going to be talking a lot about the golden rectangle and golden sections in our discussions today. Okay? All right. Now, what I'm going to do is stop talking myself, and I'm going to let Ed Berger talk to you about golden sections, but he really doesn't get into it as carefully as I did and what their relationships are. But prior to Ed talking about it, you're going to see a cartoon here from Walt Disney from 1958, which deals with this. But it's going to go back and talk a little bit about the rule of Pythagoras also, and the fact that Pythagoras is the father of music also. So I hope you will sit back and enjoy this video and listen carefully and notice the golden sections that you will be seeing in these videos as they are presented to you. So I'm going to sign off for now, and we are going to then have you take a look at this material. Okay, here we go.